All right, so in class, we were able to get through the 45, 45, 90, but we didn't get a chance to really talk about 30, 60, 90. So I just wanted to make sure that we're okay with this one. So I'm gonna go over a couple things. Okay. So when we did the dot paper, we talked about this particular triangle. If you kind of forgot, feel free to rewatch the dot paper exploration screencast. But what we have found is that we said we agreed that these were all 60 degrees. And when we drew the altitude or the height of the triangle, we created a mini right triangle. And I'm going to use my yellow crayon to kind of fill in this part. Okay. And you can really kind of use, I guess, any lengths. Even numbers work really well, but I'm going to go with our smallest triangle that we have used in our exploration, and we made them all two, which means that we equally broke up or bisected the segment on the bottom. And so now you end up with a right triangle. So I'm going to redraw it so we can just focus just on this one, 60. This is going to be 30 because we bisected the 60-degree angle. And using the Pythagorean theorem, so we did 1 squared plus a or b, doesn't really matter, I'll use a here. We got a squared to be 3, which means that a would be root 3, or I'm going to say 1 root 3. So what happens is that everything is being compared to the short leg because it's 1, so it's kind of easiest to work with. So it's easiest to see the relationships. So if you look at the two numbers, so if the short leg is 1, the hypotenuse is 2. We had short leg of 3 on our exploration, and the hypotenuse was 6. So we noticed that the hypotenuse was always twice as long. So if we just double the short leg, it would always give us the hypotenuse. And that makes perfect sense because remember that the short leg is really actually just half of the hypotenuse if you think of the equilateral triangle, because we just broke it up in half. And then the long leg is always would be root 3 longer than the short leg. So let's take a look at a couple examples. So a couple ways you can approach this, right? So sometimes you can look at the reference triangle and actually see the scale factor right away, and it's actually really helpful when it happens. So let's take a look. I'm going to redraw my triangle. So the hypotenuse is 2. The short leg was on the bottom, so now it's here, but it's 1. And then the long leg would be root 3. So if I very carefully look at my numbers of these triangles, and I focus on the length that's given to me. So here I have 8 and here I have 2. If I ask you what is the scale ratio, right, between those two figures, I'm hoping that you would tell me that it's 4:1 because this is 8 and then this is 2. And this is a really nice way to tie all of this back to chapter 6 when we started exploring similar figures. So what this tells you is that every length in the triangle on the left is actually 4 times larger or longer, right, than the length on the bottom of the little triangle, right triangle. So that means that this x is actually 4. And root 3, if I make it 4 times larger, so I multiply it by 4, it would just be 4 times root 3. And that's pretty much it. That's all there is to it. And I'll do it the other way in a second, but so let's look at this triangle here. And in this triangle, again, you can actually very nicely see the scale because look, you have this root 3, and this is 13 root 3. So the scale factor, the scale ratio would be 1 to 13. So everything in my triangle in part B would be 13 times larger. So this would be 13. And then 2, if I make it 13 times larger, would actually be 26. So in part B, x would be 13 and y would be 26. And then if I go back to this one, x would be 4 and y would be 8. Okay, So the other way that you can approach this, and what I'm going to do is I'm going to erase these numbers because sometimes it's not, the scale factor is not there like staring at you, right? So sometimes we have to do something different. So the other ways you can use the relationships within the length, the length. So for example, if you know the 8, I could see on my reference triangle, or remember that the short leg was half of the hypotenuse. So this would have to be half. I'm going to have to divide by 2. Right, so 8 divided by 2 would just be 4. And then if I have my short leg and I need to get to my long leg, I would need to multiply by a root 3 because it's going to be root 3 longer. So if you take your 4 and you multiply it by root 3, you would end up with 4 times root 3. Right, so this method is using the relationships within the same triangle. Our previous method looked at the scale factors of the triangle you're referencing and the new one. Okay, so over here, right, so I'm going to redraw quickly. So you reference the cross from 30 is always the 1. The hypotenuse is twice as long, and then the leftover leg is root 3. Okay, so if I want to go from my long leg to short leg, so again, remember you're making it shorter. So if you're sitting there and wondering, like, should I divide, should I multiply? To make something shorter, you're going to divide because my root 3 is bigger than 1, so it's going to make the number smaller. So we're going to divide by root 3 in order to get to the short leg. So I'm going to divide by root 3. So if you take 13 root 3 and then you divide by root 3, you end up with just 13. And then once I have my short leg, if I want to get to my hypotenuse, I see that the relationship is the hypotenuse is twice as long. So I know that all I need to do is just double the 13. So y would be just 13 times 2, which is 26. So we get the same numbers, but either one is, like, whichever method makes more sense to you. I'm going to pick one problem that I think is probably more challenging than others, and I'm going to pick 5. And then I'm going to let you do the rest on your own. Okay, so for number 5, what makes it challenging is if I look at my reference triangle. So I always draw in the 30 and I go across to 1, the hypotenuse is 2, and then I do root 3 for the leftover leg. What makes this one a little more challenging than others, if you look at the two numbers or the number that's given, right, 12, and you compare it to the root 3 in our reference triangle, it's not very easy to see what the scale ratio is at all, right? So we have to do a little bit of work. Now, one thing that somebody asked me in class was, can I just use proportions? And that's totally fine. So these are two similar triangles. So if you would like to use proportions, you can absolutely do that. So you could say like 1 to root 3 is the same ratio as x to 12. Works totally fine. So I'm going to go ahead and do this. So if I want to go from a 3 to 1, I need to make the longer leg shorter. So I'm going to go ahead and divide by root 3. So I'm going to have to do the same thing here. So we're going to divide by root 3. So 12 divided by root 3. I'm going to rationalize. And then I get 4 root 3 as my answer. And for 12, for y, so to go from my short leg to my long leg, if I will go from 1 to 2, I would need to double. So I'm going to do the same thing. So here, I know that this is 4 root 3. And to go to the hypotenuse, I'm going to have to double this. So the hypotenuse, which is y, will be 8 root 3. Remember in the warm-up we talked about how when you multiply, the rational numbers can be multiplied together. So root 3 just kind of stays there, but 4 and 2 can be multiplied. So that is for your number 5. And hopefully this makes sense. If it doesn't, or if you're confused about something, just email me.